So, to give you an idea of how density is affected by temperature and salinity in the ocean, I have this picture right here that shows you how density, which are these numbers right here, are affected by each. So as you can see, the numbers here represent density. So that means this is 26 all the way through, even though there are different salinities and different temperatures. Salinity increases, typically resulting in an increased density. So as you can see, the bigger the salinity, the bigger the density. That's because you're adding more mass in a volume. You're adding more salt in a volume of water. Now, the colder it gets, the higher the density as well. So if you look at it this way, two volumes of this, two vessels of the same volume of water, one is cold water and one is warm water. The cold water is going to have more mass in the volume than warm water, because warm mass, warm air, warm water, whatever substance, when you warm it up, the atoms start to get agitated and move away from each other, so they take up more space, and therefore you can't fit as much mass in that same volume than if you made it cold, which when something gets colder like this, the mass is condensed, the particles are getting tighter together, closer together, and so it becomes denser. So in essence, there's more mass in a cold vessel per volume than in warm water. So the colder it gets, the lower the temperature, the colder it gets, the more mass you have in that volume, so the higher the density. So you can actually have, as you can see here along the 27 line, you can have a volume of water that is very salty and warm have the same density than something that's very cold but fresher. So water typically stratifies or layers if it's different densities. So the different masses, the different mass per volume or density makes it not mix. But if you have water of the same density, it can mix. And we refer to that as coballing, which makes it unstable water, and you get mixing as opposed to stable layered water. Now looking at this image below, you have the thermocline, halocline, and picocline, which are the rapid change in temperature, salinity, and density as you go down into the ocean depths. I want you to notice that the deeper you go in the thermocline, the colder it gets really rapidly along this area, the top 1,000 meters. That means that in the top 1,000 meters, the temperature drops really, really quickly, and no matter where you are in the world, below that, you have the bottom 80% of the ocean being the same temperature. Whether you're in the tropics or the polar regions, it doesn't matter. If you're below 1,000 meters, you have the same temperature. Now, if you look at the halocline, you may notice by looking at this image, let me see if I can expand it here. The halocline actually shows a rapid decrease in salinity as you go down. This is in parts per thousand, which equals 1. There's 35.5 parts salt in every 1,000 parts of water. As you go down to the top 500 meters, the salinity actually decreases, which means that the surface water is actually saltier than the bottom, which doesn't make much sense if you recall. The more salt you're adding, the more mass you're adding, so there should be more mass in that volume, which should be denser. But as you go down, it gets fresher up to a certain point and then it increases again. The reason for that is that the temperature here must be a lot warmer, like in the tropical regions where you have evaporation and less precipitation. So temperature actually impacts density more than salinity. This must be warm enough for that warm, salty water to stay on top of this colder, fresher water. Two factors affect density, salinity and temperature, but temperature has a bigger impact on density. Now, there's two things that affect density: evaporation and precipitation. If there's more evaporation, you're going to get more salt being left behind on the surface water, so it's going to make it saltier. More precipitation equals more rain, it's going to make it fresher. Now, the pycnocline is the combination of the two. As you go down, the density increases. So, as you go deeper into the ocean floor, to the top 1,000 meters, you get this rapid change in density, and then it stabilizes.